So after looking into the basics of the web, some add-ons that are quite important. Cookies, proxies, scaling, and then a special topic, DNS over HTTP, that combines those two words. So, what was the key idea of HTTP? I told you that basically, in the very beginning, it was a stateless protocol. And the classical HTTP is still stateless. Okay, that means if you request a resource, you get a reply, and after that, the server forgets everything. So request, reply, classical situation. So you request the index, for example, the server replies. And then the server can free resources here and forgets about everything. So that's the simplicity of HTTP. You can scale it for a large user base, little processing, little memory footprint, so that's fine for browsing. But what is a big disadvantage? You cannot store any context. You cannot personalize answers. So for example, the server here could know, okay, there was already the customer X, so the next time X comes by, I can say, oh, welcome a second time, and this is a special offer for you. In the classical setting, HTTP, the server doesn't know anything, so you cannot personalize user experience. So you cannot create real online shops that want to remember users. So there indeed was a request for user tracking. There's always good and bad with user tracking. Nowadays, companies collect a lot of state. So this is not only tracking for customer returning to an online shop. That's much more. It's exabytes of state about users identified by cookies and some other solutions. But first of all, what is the solution? So HTTP request reply, server forgets everything. We do not store any context. But maybe we want to have a context. By the way, this really looks and sounds like a session layer of the classical OSI model, where we have all these 7 layers with a session layer in between. So we can go back to a certain kind of a synchronization point where you say, okay, the customer already has been here, and then start from this point on. So the classical solution for storing state are cookies. So cookies are quite simple. These are tags assigned by the website, and the web browser, that means your browser, stores this state. This also gives you a chance to delete the state, to clear all the cookies. So therefore, store the cookies. We have an additional HTTP header field, set cookies. And the idea is this instructs the client, your browser, to store the received cookie together with the server name. And the next time the client accesses the server, it can tell the server, hey, it's me again, indicating the cookie, and then the server can identify you, your second, third, etc. visit. In parallel, the server can also store some information about you. So you, on the client side, you store an identifier, and the server can then store whatever the server wants to store depending on the website. So how does it work? So we have the cookies. The cookies, basically, it's a classical name-value pair. It tells you, okay, we have a certain domain, and then we have a content, customer ID, some preferences, a user ID, or whatever there is, and there's some optional components like, for example, a comment or an expiry date, etc. So that's the idea. So it's a name and a value, and then it depends on the usage scenario if this value is a customer ID, status of a shopping cart, or whatever. So that's basically the idea. What you cannot control as the client is what the server stores about you. Well, you don't know. And what the server does with data. What you can do is actually you can delete the cookie, you can check what cookies you have, so that's it. But you don't know what the server is doing with it. But that's the idea. Okay, so to delete a cookie, it's quite simple. You can resend cookies with expiration time in the past, etc. So the idea is that you, as the client, you reveal a certain identity to the server, and then the server can act. Well, depending on the type of the website. So an example for this. So here you see the client host. It's always here on the left. And we see the server. And the first time you access something, okay, it's the usual request. You send over to the server. We ignore all these TCP, etc. things. It's all simplified. And then the server says, okay, I create a certain ID for the user, and you enter this in a database. So whatever, in addition, maybe the time, the date, and maybe something the user looked for on the page, etc. And then you respond to the client, now please set this cookie. So locally, your browser stores this information. Okay, so then you have, in addition to the cookie you had before in this example for eBay, now maybe you have yet another for Amazon. That's the idea. Okay, and if you access now with a normal HTTP request, the server again, you send the identification of the cookie along with this request. And then the server, whatever the server wants to do, access the databases and does something. This can be done immediately as indicated here, and then you get the response, or you can do this a week, a month, a year, whatever later. You request, and then the server again checks and tells you, oh, you're back after a week or after a year, whatever, and sends you the response. So that is the idea. So basically the cookie is the key into our backend database. So very simple scheme. So what do the cookies enable? Well, you can create shopping carts, recommendations, you can store session state without cookies. Well, you will have some problems with certain web email systems. You can use it for authorization. So basically you manage state. So it's HTTP, which is stateless, with a persistent identifier. So that's the idea. The identifier is controlled by the server, stored on your local machine. So that's the idea. And you maintain this state over multiple transactions. And it's very simple, all the management. The main problem and the big discussion is, well, what about privacy? So you can look in your browser and check how many cookies you have. There's probably hundreds of them. And but what you cannot see is, what does the server side do with your cookies? And does the server side, whatever, get some additional information out of the cookies? Or, for example, do the servers somehow cooperate and not match cookies, but bring it together and see, you were shopping at this company and then at that company, and you bring it somehow together. So there are companies that store thousands of terabytes of information of the behavior. And this is basically forever. The internet doesn't forget anything, so you don't have control and you don't know how long this information is stored. So it doesn't help to delete the cookies on your side. This helps only partially, so you can a bit at least hide your browser from the company, but not completely. So cookies, that was the beginning of actually, tracking behavior, storing state. There are some more things. I showed you together with the HTTP request response something that's called an E-tag. So an so-called entity tag as part of the HTTP request. That is also an identifier, but this time this is an identifier assigned by the web server to a specific version of a resource. So the server can say, okay, this picture, for example, has a certain tag, and that's the version of a resource or of a text, whatever, so that you know, okay, it's not only the name of the resource, but this specific version. And the idea is you change the e-tag only if the resource is changed. So that's basically a fingerprint of a certain resource, so that you know if the e-tags are the same, it's still the same resource. But so the browser then submits a request together with the e-tag for a certain resource, and the server can repeat this. And basically, by following the e-tags, you can follow this in literature, by following the e-tags, you can also, well, get a behavior like these persistent cookies. So the server could go ahead and associate one e-tag per user, allowing for tracking. So we started with stateless for good reasons, scalability, etc. We needed a solution for at least keeping some state, and now we have more and more ways of keeping track of users for good or bad. So the problem with the privacy is cookies tell a lot about you. So if you have these hundreds of cookies, so you don't know what they are used for, you can disable them, but some of the web pages, they do not really work. So you can accept them, simply accept all tracking or nothing, and sometimes things will not work. So there's also the idea of global tracking with cookies. So the goal here is to get information about all online activity, to get some information. And that really is big business. So there are deals between the content providers, so those companies having the content, and companies like DoubleClick. So DoubleClick collects then all the information. And the point is that yes, you may disable certain cookies, but the tracking can go on with, for example, certain ad banners, and then there are ad blocking add-ons, etc. So yeah, that's a classical game, who's using what technology to track you. And today, many companies do not care about cookies any longer. There are different cookie-less tracking technologies. So you can use JavaScript, caching mechanisms, the already mentioned e-tags. So here you have a link that gives you some more information. So that really is a problem. You can find out, for example, the certain behavior of users, or use JavaScript, for example, to find out certain settings on your computer. So the combination of operating systems and installed programs plus their versions, etc., to create a unique fingerprint of you and your machine. And this will tell companies a lot. So there are some approaches against this kind of tracking. So there are certain private modes in browsers where they automatically remove this tracking. Sometimes some pages will not work any longer. Some pages behave a bit strange. So some companies try to do something against tracking, but it's always a question, how do you make money? If you offer a service for free, well, remember, there is no such thing as a free lunch. So you have to make money any other way. So if you don't sell it, then you will maybe get money out of this kind of marketing. So it was maybe a good idea to start with stateless HTTP. What is the advantage, but what is the disadvantage, and why do we need state, and how can we introduce state? But as soon as we do it, we start having some problems. So what are the problems, and maybe how can we avoid them?